Hello and welcome to another episode of the Geotechnical Engineering Podcast, a podcast focused on helping geotechnical engineers stay up to date with technical trends in the field. I'm your host, Jared Green, and I've practiced as a geotechnical engineer for over 18 years. And in addition to practicing engineering, I enjoy mentoring young engineers and first-generation college students. I have focused on helping to increase the number of pre-college students that are interested in STEAM majors and fields. By STEAM, that's science, technology, engineering, art, and mathematics. In this episode of the Geotechnical Engineering Podcast, I'll be talking to Roch Player, the Chief Engineer at GeoStabilization International, about the role that geotechnical engineers play in design-build projects. After earning his BS and MS degrees in civil engineering from Iowa State University, Roch began a 20-year career in the geotechnical consulting industry with projects throughout the United States and Canada. In addition to his professional consulting experience, for 2 years, he taught geotechnical and foundation engineering as an adjunct instructor at the University of Texas in Tyler. He's a licensed PE in Alaska, Iowa, Louisiana, Minnesota, Texas, and Washington. And Roch has experience in both traditional and alternative project delivery, specializing for over 15 years in design-build delivery of major infrastructure projects, including major bridges, highways, airfields, and Department of Defense facilities. Roch has authored several papers on the geotechnical use of geographic information systems, also known as GIS, and he remains active in civic, professional, and religious organizations. He's a member of the Lions Club. He serves on his local board of adjustment and is a lay minister in his church. Roch has been married for over 20 years to Shireen Hansen Player and is the father of 4 daughters, Laura, Clarissa, Sadie, and Margaret. And with that, let's jump right into our conversation with Roch Player.
Anthony Fasano here from the Engineering Management Institute. Before Jared transitions to the main segment of today's episode, I would like to jump in here and recognize our sponsor for this episode, Menard USA. Menard USA is a specialty ground improvement contractor that works nationally providing design-build ground improvement solutions at sites with problematic soils. Menard works closely with civil, structural, and geotechnical engineers to minimize foundation costs for wide ranges of soil conditions, structure types, and loading conditions. To learn more about Menard Group USA or for help on your next project, please visit www.menardgroupusa.com. That's www.menardgroupusa.com.
All right, welcome to another episode of the Geotechnical Engineering Podcast. Roch, glad to have you here. How are you doing, man?
I am outstanding. Thank you. Glad to be here today.
Excellent. Well, I'm glad that you're here with us. And I already gave an introduction, I read your bio to our listeners, but in your own words, can you tell us a little bit more about your career path and also what is it that you do at GeoStabilization?
I'll start with what I do because it kind of is where my career path is going. I am the chief engineer with GeoStabilization International, and we're a specialty geohazard mitigation company where we are the integrated design build firm where we help our clients fix their geological geohazard problems. And how I got to this point in my career was began as a young man, very young. My father is an engineering and petroleum geologist, and I would go out with him on site and see what he was doing out there and follow along. And he's the one who kind of guided me into geotechnical engineering because I was thinking going pure geology. But as we know, being a geologist is a little more cyclically employed versus having a civil engineering degree and being able to do a lot of the similar things, but able to have the PE after the name. So I went to Iowa State, where I finished my bachelor's, did my master's, and from there began working at a consulting firm. And while I was at the consulting firm, I had the opportunity to be exposed to a lot of different things, particularly design build, and that became my passion. I'd been in the industry a little less than 3 years when I had my first opportunity to move to Alaska. And it was CH2M Hill who was with at the time and work on one of the first design build projects in Alaska. And one of the first ones done by since the feds authorized DesignBuild back in 2000, and this was in 2001. And I got the bug. Being out there, making decisions as an engineer and seeing them actively implemented, seeing where I was wrong and seeing what it was right. And it harkened for me back to the original days, the Carl Terzaghi and the observational method of geotechnical engineering. And so from that, I moved around the country doing heavy civil design build jobs, and then in between the jobs, doing general transportation and other geotechnical consulting, part of a full service firm. And then been doing that about 15 years, and I had the opportunity to return to Iowa, where my wife's family is. Changed careers at that point, went less from the full service to more of the niche geotechnical firm. Had a great experience. But while I was there, I was wanted to continue to do design build work, and we worked on a project with GeoStabilization International. Met the principals there and became very enamored with the opportunity to continue to do design build work, but focus more on the geotechnical engineering. And so about 4.5 years ago, I came over here. So my career path has been following my passion, and my passion's moved me all over the United States. And my wife and kids were part of that whole decision-making process. We went from Iowa to Alaska to Washington to Texas and back to Iowa. And then I sit in Iowa and work all over the country now. And geotechnical engineering and the opportunity to have a real impact upon people's lives and infrastructure is what's driven me. Because there's two big uncertainties in every project: where you are and what are you building on top of. Yeah. And without a thorough understanding of either of those two things, the project will not be successful, and the goal of the project will not be accomplished. So as a geotechnical engineer, I've been very fortunate in the course of my career to work closely with all the disciplines of civil engineering to come up with solutions and help guide the decisions that we make to build infrastructure.
That's awesome. Sounds like a very rewarding path you're on there,
It has been. It's been very professionally rewarding for a family. It's been very personally rewarding as well. We've been able to meet wonderful people all across this country. And then as I've grown in expertise and opportunities to serve, it's given us a little more flexibility to sit where we want to sit. And so we went back to Iowa in summer of 2013. So the kids be closer to grandma and grandpa, and we could finish raising them. And 4 were out of the house, and got one left at home.
All right, excellent. So you mentioned design build. I'd like to talk a little bit more about that. And we have an appreciation for design and construction and what that means for a project, but sometimes people don't really think about all the planning that goes into, let's say, laying the groundwork to ensure that the safety of the public is accounted for, and also to minimize the impact on the environment. Can you tell us a little bit more about the planning process? I mean, what are the things you're thinking about? What are the things that you're trying to unpack?
You bet. For me, the core of design build is that considering in the design how it's going to be constructed. Often, I spent 20 years in the consulting world, and a lot of it was bid build type work, where I had, as an engineer, had to make some assumptions and make some decisions about how things are going to be built, and I didn't know who was going to construct it, and so oftentimes I would have to make the assumption that it would be the lowest bid, which means oftentimes the lowest quality, and so I'd have to be very, very specific in my specifications and be conservative in my assumptions. All these kind of things are just engineering design, and that would just build on itself. With design build, I have the opportunity to consider not just what needs to be built, but who's building it. What are the tools that are being used? What are the means and methods that are going to be implemented to be able to accomplish the goal of that project? And so in the planning process, as the engineer, sit down with the person that's constructing it, we start talking about such things as how can we access the site? What are the logistical implications? Where's material coming from? One example that I'll give just as an anecdote was I was working on a project in East Texas, and we were replacing a bridge in part of the design build value engineering process with a large box culvert, but that necessitated a really high fill, like a 60-foot high fill that would go over the top of it, and it was in bottom land settlement issues. And so we had a very, very, fast schedule critical. So with it, what can we do to improve the ground so that we could build this high fill? So we thought, what about stone columns? I'd used them successfully in other places, looked like a great application there. But then I started talking to some specialty contractors, and they're like, no, your closest usable stone source is 150 miles away. So the cost to put in these to put in stone columns would be astronomical. And so that drove the decision making for what design. And so what we ended up going with was a stage surcharge program utilizing vertical wick drains. And we were able to accomplish it, what we needed to, with long linear project, move things around. But that whole conversation in the design build world is that back and forth. Okay, what do we want to build? How are we going to build it? What are the technical requirements for that to be successful? What are the codes that it needs to meet? All the same standard of practice, standard of care applies. We're just tying it together with how we're getting it in place. One thing I use with my young engineers is we cannot wish things into place. It doesn't matter how well the calculates, but if you have to wish it into place, it's useless.
Yeah.
And so that planning process, that coordination, that healthy tension between the design and the construction ends up coming out with a better solution that either one alone could make.
Agreed. And, there's so many different delivery methods for projects. Just talk us a little bit more about the design build delivery process, and what is the one that you use or have used?
You bet. There's design build is a large overarching term that means basically that the person designing the project and the person building the project operate underneath the same contract. So rather than an owner hiring a designer to produce plans and then goes out to bid, and then I'm hiring the contractor to construct those plans, they're working together under the same entity. And it might be a joint venture, or it might be the same company. Regardless, it's one contract that covers that. And it's not the panacea for every project, but it provides a great tool to be able to accelerate the decision-making process and provide and return on the owner's investment more quickly than a typical design bid build process. And for me also, that's kind of old school, because the Robleys who built the Brooklyn Bridge, they were design builders. The pharaohs who built the pyramids, they were design builders. What we do with the bid build environment is a relatively young, I wouldn't even call it innovation, young way of doing things. It was really driven by politics less than efficiency for design. Maybe that's a little controversial, but I don't care. That's how I feel.
That's your story, and you're sticking with it.
That's right.
Awesome. So, we start thinking about sole sourcing responsibilities of an owner, as well as the contractor during projects. What do you think of that?
Well, I think it's that the big thing is who can best manage the risk.
Yeah.
And the owner, when doing a sole source contract to an individual, it doesn't mean that the owner is giving up control. It doesn't mean that the owner is ceding responsibility to the design build developer. It means that the owner has made a decision that this entity can better manage and better control the risk that they experience. Some owners are not very sophisticated, and they don't have the ability to take on all these different nuances of the projects, and that's okay. We don't expect them to, but they need to be able to, you put good terms and conditions together. It's a legally binding document. Everybody works within the rules. It's a risk management technique, and because there is this sole source entity that's working for the owner, they still have the same obligation to meet the codes, the standards, the quality. The other big thing with design build, there's often warranty associated with it. We're in bid build projects, there's usually nothing more than a quality warranty, or the terms escaping me. But design build project, there's generally a warranty period that design build developer owns to as part of the risk management for the owner. And for me, I've heard some critiques of design build is that the engineer and the contractor are in bed together and but it's like, well, do we honestly think that all contractors are corrupt? and that there's some reason they're going to try to take advantage of people. You get the right team of people that are ethical and want to work and are dedicated to the success of the project, the success of the owner, the success of what we're doing to build infrastructure or repair infrastructure. That our ultimate goal, of course, is still as an engineer is to protect and serve the public. That seal that we have is what is the ultimate authority on any project, because even at design build or design bid build, we can't build something legally without that seal. Yeah. And we're still responsible for what that product is that's going out there.
Yeah. And in the end, everybody wants it to be a successful project.
Everybody wants to be a successful project. And so I think with design build, it also gives us a better opportunity to understand what the owner's definition of success are and work towards that. Yeah. It takes planning, it takes upfront conversations, it takes dedication to the team and the owner's goals. But when it's done right, which is most of the time, it is very successful in meeting those goals and accomplishing what the owner wants to accomplish.
Absolutely right. And then, you think about architecture and also as engineering, they're very high risk professions. You think about when you're putting that seal on a drawing, a minor error in a design can lead to delays in construction or other significant losses, resulting in potentially costly lawsuits. Tell us a little bit more about the architect and engineer liability gap. What is each one's role and how do you avoid gaps in coverage? Because that's always a pain when that happens.
It is. It's the question is kind of who is on first, who is responsible for what. And it all comes down to communication. There's certain things that have to be done in every project, and identifying who is responsible for what and when upfront, setting the understanding, setting the standards so that things don't fall between the gap. And being proactive in the communication. I think sometime with engineers, we tend to jump right into trying to solving the problem. And we forget that the problem is only one part of an overall context in which the project and what we're doing sits. There's economic, there's regulatory, there's environmental, there's finance, there's the specific finances for that project, the micro versus macroeconomics, all these things. And our project is just maybe one piece of it, and the lateral earth pressure on the retaining wall is one very, very, very tiny portion of that. But that's what we tend to go first. Yeah. But we get right into that. And so that's where these gaps are not natural. These gaps are as a result of taking what we're doing out of context. And so we can overcome those gaps by saying, okay, what's the goal? What are the definitions of success? What are our constraints? And identifying all those things before we ever dive into the solution. So we set the context, we set a table where we can be successful, and we can make sure that things aren't dropped, because then we continually communicate and look back. Are we accomplishing the goal? Are we accomplishing the goals? Have the goals changed? What do we need to do adjust for those things? And then we can overcome that. But without that, when we're in this, I'm the architect, I'm the engineer, I'm the constructor mentality, there will always be gaps, and things will always fall through the cracks. That's why when I'm a big advocate of design build, is because we, by contract, eliminate those barriers, and we got to better well figure it out, because we're all responsible together to that owner.
Yeah, you're in it together at that point. You're absolutely right. So, we might have some younger listeners that aren't too familiar with constructability. You were talking about, something being wished into place. Yeah. Can you explain a little bit more about, what is constructability? How do you know something's constructible, and how does that factor in risk management as well?
That's a great question. I will define constructability is that which we're proposing to do able to be built using the means, methods, and materials which are readily available for that project. So, and that's where I get into my, it's a fun little phrase, don't wish something into place. Is that we have to look again at the context of what we're building and how we're going to build it. We need to look at schedule. We need to look at sequence. We need to look at the expertise of the contractors there. So, for example, I am not going to specify using concrete pile in Alaska. Not going to do it because they don't drive concrete pile in Alaska.
Yeah.
And to be able to do that, it takes a whole new spread. All that has got to be mobilized up to Alaska. What they like to drive in Alaska are large diameter, open-ended pipe piles.
There you go.
So that's the go-to. And technically a concrete pile of work or a drilled shaft of work or an auger cast pile of work, all these things would work from a technical standpoint. I can do all the math, but who's going to build it? Or who's going to build it efficiently? And we don't want our owners to be put in a position where they're paying a premium for something because it's our preference. The best solution is not always that which technically we think is the best. It has to meet the technical, of course, but the best solution is a best value that hits all of the success metrics for the owner. And that's something that's constructible.
There you go. Great answer. Great answer. And, when you start thinking about a standard of care for engineers, how do you implement that into a project?
Well, we got to know what the heck we're doing. The same rules apply to anything. As an engineer, I am not going to take on something that I am not competent to take on. That's the standard of care. We have to say, okay, I am an engineer. I'm a geotechnical engineer. I can design X, Y, Z. I am not a structural engineer. I cannot design a two-way reinforced post-tension slab for a 6-story high-rise building, even though I have a PE after my name. Yeah. I have to understand my limitations and be humble, because the geotechnical engineer in particular, the earth will always prove us wrong. No matter how long we've been in this business, the earth is going to do something that we're like, oh, what?
Yeah.
And so the standard of care is being humble. And then the other thing I teach young engineers and talking about is have a narrative behind every decision that we make. So if I say this soil has a phi of 28 degrees, why did you choose that? How can I explain it to another practitioner, or how can I explain it to a novice of how I made that decision? If the answer is, well, that's what I always use, that's not a narrative. That is not an excuse. If I ask her to say, based on previous experience, we've successfully used 28 degrees because of these different projects we've been on in similar soils and similar materials, that's a narrative. And so the standard of care is being humble, being able to explain what we're doing, and then not taking on something that we're not qualified to do.
That's great. That'll keep you out of a lot of trouble.
Yes. It doesn't mean physics change when you cross the state line. And we have to understand, that's the other thing I'll just add to that, is that we have to understand fundamental first principles of engineering, mechanics of materials, the just physics, statics, dynamics, and mechanics. If every engineering discipline is based upon those three basic concepts. And when we understand those, then we can apply them to new circumstances, which we've never done before, if we look at them in the fundamental first principles. But we also have to be humble to say, well, this is so much out of what I've used to do. I know what to do. And I need somebody who's an expert to help me with this, to teach me this, or to do it. But I'll summarize all that. But the fundamental first principles, we have to understand. We can't get away from that, because if we don't understand those fundamental first principles, we're no longer engineers. We're technicians.
Yeah, you're absolutely right. And it's definitely a difference there. Definitely a difference. Let's talk a little bit about construction estimation. So what are some of the processes and challenges that you face when determining a construction estimation, trying to figure out how much is this going to cost, right?
How much is it going to cost? The estimating is an art. It's kind of like geotechnical engineering. It's an art as well as a science. And so what we do with estimating is we first have to understand what the goal is. Go back to, again, what we've talked about before. We have these fundamental, what's the success metrics of this project? And then what are we going to do to accomplish that? And then basically an estimate is, what is it going to take to accomplish that? So we know what we're going to do, but now what do we got to do what does it take? And so then we start looking at, okay, this solution, we need this kind of access, this kind of equipment, this kind of materials, and the number of people. We start adding all this, and basically, for me, an estimate is building on paper first before we go out and build it in the field. And if we've done our estimate right, what it takes to do out in the field should come in pretty close to what you figured out on a piece of paper. What's helped me with estimating most successful is utilizing those people who have been down the road before. We have a group of professionals within GSI that are, been in the business for 30 plus years. And we can sit down and say, okay, this is the site, this is the access, and this is what we propose to do. And we talk to each other and they say, yeah, you need a 15-degree soil nail on this, but the equipment to reach that, you're going to have to go to a long reach to get down there. Oh, we don't want to do a long reach because we don't have room to put it on here because we only have one lane of traffic and then we don't have a wide enough. So what can we do to do differently? And so we come together as an integrated team to figure out the solution. And then we start adding to that. I say, okay, our average installation for a complete soil nail in the ground is X number of feet per day. And so that equates to this number of crew days, which equates to this number on the crew, which equates to $10 a linear foot or whatever. And then we roll that up. We look at it two ways. We look at a bottom-up estimate where we look at every single piece and that adds up to what the cost is. And we'll look at a top-down estimate where we look at just general numbers like, okay, we need 75 soil nails and they generally cost us $1,000 each to put in. So this project would be $75,000. Come up the other direction, we're at 78,000. Alex, we're pretty good. Okay. But again, the fundamental principle is we build it on paper first, and we account for all of those costs that will be associated with building that thing, from material to workforce, and then roll it up, and that's the dollar that's going to cost what was in our head.
So it just goes to show you, in order to properly do that, you need to understand how these things are built.
Yes, you have to. So as a young engineer, one thing I would highly recommend is get on a design build project if you can. If not, volunteer for the scuddiest work that's out there, and just go out and see it, and talk to the old guy on who's the operator, and just watch construction, be involved, design build, especially with us, since we're a contractor. I can pick up iron and not get in trouble for it. But, when I was in different entities, I'd have to watch, but I kept my eyes open. I looked, I took pictures, I took notes. And so I gained an understanding of what it takes to do the work that we do. And it's improved how I am as an engineer. And the more time I've spent out in the field around implementing solutions, the better I've been in coming up with those solutions later.
Yeah, I agree. You learn so much when you're in the field, so much. And when you just watch things go together, it may seem like, it's just moving so slow, but the days add up to weeks, add up to months. And you say, wow, this was a parking lot. Now it's a 60-foot hole in the ground, right?
Yes. Right.
Fully supported. How did that happen?
And then like, I got pictures and we can do this and this is what they did. And what if we did it this way? And you have all those fun conversations, and that it brings, life to the work that we do.
Yeah, no, it really does. Well, before we take our break, talk to us a little bit more about how your company ensures that they follow and maintain professional responsibilities, because that's super important.
Yes. One of the things that we talk about a lot in the geotechnical profession is the continuity of professional responsibility. You'll write a geotechnical report, you give recommendations, then you say, and you should hire us to do the construction oversight because we were the engineers that gave the recommendations, and to maintain continuity of professional responsibility. Yeah, we know in the geotechnical consulting world that is not always the case. It is sometimes it's very it's the rarity where things are always all the way seen through. In design build and the work that I do and what I work with our young engineers on is that we are responsible for the projects from conception to ribbon cutting. As the engineers, we are involved every step of the way. We may not be the person in the lead during construction, but we are there involved. We see what's happening. As geotechnical construction is dealing with geology. And so you drill a hole here and drill a hole 4 feet over and maybe completely different ground conditions. Mm-hmm. And so as an engineer, we work with our team that's out there installing the solution and making sure that we get that constant feedback. Every boring that we get every nail we get is a soil boring. And we understand better what the subsurface is, and we update our models, and we make sure that that which we're building is meeting the goals based on the existing site conditions. And so for that continuity of professional responsibility, it's being involved every step of the way. That which I had in my head goes out on the plans, but I'm not perfect in my translation from my head to the plans. And so if I'm not out there in the field, or my representative out in the field, making sure that what I intended is being built, then there is, again, we talked earlier about a disconnect between, there's that disconnect that goes along as well. And then at the end of the day, my professional license is on the line every time.
Yep.
I am responsible. I have to meet the codes. I have to protect the public and the environment. That is my obligation that I took on by becoming a professional engineer. And there's nothing and no one that can supersede that. And so I have to be protective of that and what my obligation is beyond my company to the public. And so as when I try to instill that fear and that awe and that responsibility into young engineers, particularly the newly minted PEs, is that it's not a light thing that we do. We as engineers have done more to improve the health of people, to improve the environment, to improve the economy than any doctor has done. More civil engineers have saved more lives than doctors, but definitely save more lives than lawyers. And we have done more to build this nation than anybody in Wall Street. We undersell ourselves and what our value is to our society.
Yeah.
But we need to remember that's where we sit. We are, pun intended, the foundation upon which modern society has been built, and that which our future sustainable society will also be built. That's our job as civil engineers. And as geotechnical engineers, we got to lay the foundation for all of that. So I guess I'll quit babbling.
That's very powerful. We'll pause on that one, and then we're going to come back in a minute and close this one out with Roch and our Career Factor Safety In segment. Stick around. All right, welcome back, everybody. It's time for our Career Factor Safety In segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your actual career? Well, today, of course, we're speaking with Roch Player. Roch, you've had an already successful career. When you look back on your career, what's one thing you implemented in your career to give yourself, let's say, a factor of safety?
That's a great question. And I love that concept of the factor of safety. I think there's maybe two parts of that. Number one, be willing to do as many different things as possible. And number two, be willing to go anywhere you need to go. And between those two things, you can develop. So for example, when I was in undergraduate or graduate work, I learned GIS. I was back in ArcView 2X, a long time ago. Because I maintained that GSI or that GIS capability in my career, there was a time when I was in Alaska where we were really light on the core geotechnical work for transportation. But I had the opportunity to be the GIS guy for a big environmental impact statement for a North Slope oil and gas field. I didn't say, well, I'm a geotechnical engineer, I don't GIS work. I got into it. I learned, I provided the value with the skill set I had, and it deepened my understanding of utilizing those tools, which I was able to use over and over and over again throughout my career, utilizing GIS to solve geotechnical problems. But I learned that. I got involved with the different, in these design build projects, we have these task force meetings where with the structural and the drainage and the roadway. And I would attend all of those and learn as much as I could about site distances, about drainage areas, about flow, about scour, all these kind of things from all these different disciplines, enough to be able to add more and more value when I had the conversations with those folks. And so the factor of safety that I built into my career was I stayed curious and I made myself an asset to those around me beyond what maybe my mini job description would say. And then coupled with that is that I took opportunities to go and do things which others might not have wanted to do. I discussed them with my wife. We made a decision as a family. But for example, I went out to a village in Ruby, Alaska, which is only accessible by airplane during the winter and barge on the Yukon River during the summer. And we built a washateria out there, which is basically a self-contained laundromat and water treatment plant. all supported on these thermosiphons. Long story short, I was out there, it was me and it was just supposed to be observing things and the guy building it. He saw me there, sent his laborer home, and I laid out with him the entire site with the plumb blob I bought and I brought my cloth tape and my pea shooter. I laid out, I think it was 40 piles, helped him mix the sand, put it in, all the stuff that wasn't my job. And probably our health and safety department probably wouldn't be too happy if they heard this, but did all this stuff. And when everything was surveyed back in the end, we were within a 1/4 inch, which was which within the tolerances. But we just did it. Something needed to be done. I did it. And I did it in this place that I lived in a guy's basement. And I it was, not comfortable, but I learned so much about just the practicality of how you do things. And over and over and over, as I've taken on challenges which are outside my comfort zone and been willing to do it and add value to help, that developed my factor of safety, so that I've got a broad base of geotechnical understanding that I've been able to apply in so many different ways to help. And even when things have been slow, I've been able to find something that I can do to help, and not be so focused on what I've done in the past that I can. That's my factor of safety. Stay curious and go do scut work if you have to.
Absolutely love it. Well, thank you so much, Roch, for coming on and for sharing all these great insights with us. You share some great information and advice that I know is going to be helpful for our listeners. Now, if a listener wanted to find you, what's the best way for them to reach you? Email you want to share, or you're on social media?
Yeah, I'm not much on social media.
It's all right.
I do for email. It's Roch ROCH.Player PLAYER at GSI Gary Steve Indigo.US is my work email. And then I tell old am, my other one is Roch Player, all one word, ROCHPLAYER at Hotmail.
Wow.
.com. So either those are easy ways to reach me. I'm on LinkedIn as well. I do have an Instagram account, but it's mostly for stalking my kids. And but that's about it for our social media goes for me.
That's awesome. Well, Roch, thank you so much. Appreciate you being here.
Absolutely. Thank you.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 26, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all your geotechnical engineering endeavors. Peace.